of group. I hope you like these videos. If you like, then share with your friends. And if you have not subscribed, then subscribe this channel. And if you have any question, then comment me. So let's start definition of group. So we'll first take a set is like we will taking 1 omega square, and we will taking a binary composition star, which can be addition, multiplication. So we will take multiplication, a binary composition, to understand this definition of group. So now, if the set with this binary composition star satisfies some properties, then we say that the set with this binary composition generates group. So what are these properties? First property is closure property. So closure property tells that if any two elements A, B belongs to set S, then this is belongs to set S, then A star B must belong to the set S. In this way, for all AB belonging to the set S, A star B must belong to the set S. Then we say that S is closed under this binary composition star. So here we have taken 1 omega square. So here we can check that 1 omega belongs to S. Omega square under multiplication, we will get omega cube, which is equal to 1, which belongs to set S, and 1 omega square is omega square, which also belongs to the set S. So here all these elements in the set S are under multiplication composition, binary composition is closed. So we will say that S is closed under binary composition multiplication. So S is closed under binary composition multiplication. Now we will check another property, which is associative property. It tells that associative property, it tells that any three elements A, B, C belonging to the set S, if we have under bracket A star B star C is equal to A star under bracket B star C, then we say that the set S under binary composition star satisfies satisfies associative property. So we can check that 1 multiplication omega square is equal to 1 multiplication omega square, which is actually equal to 1. So the set S under binary composition star satisfies associative property. So we said that S is associative under binary composition star. Now we will try to find out identity element. Element means if we take two elements A, B belonging to a set S, if A star B equals to B star A is equal to B, then we say that E is the identity of the identity element of the set S. So here A star B and B star A. So here E is the left inverse of B, left identity element of B, and here E is the right identity element of B. If both are equal, then we say that simply that E is the identity element of the set S. So E is the identity element of set S. If we check the example 1, if we take identity 1 omega is omega, or omega multiply 1, we take omega square multiply 1 is equal to 1 multiply omega square is equal to omega square. So we can check that 1 is the identity element of the set S. So 1 is the identity element of the set S. Of S. Now the fourth property is inverse element property. Which tells that for any two elements A and B belonging to the set S, for any two elements, if A is the identity element, we have taken A is the identity element, so we will have and we have taken any another element C. There exists a element C such that B star C is equal to C star B is identity element. So we will say that B is the left identity element of C, and here B is the right identity element of this element C, which is equal to the inverse element of B, which is equal to the identity element A. So simply you can say that B is an inverse element of C. So you can say that B is the inverse element of C. So in this way we can use this, that there are four properties. The set is satisfied under binary composition star of the set 1 omega omega square under multiplication satisfies these four properties: closure property, associative property, identity element property, and inverse element property. So we can simply say that S generates a group under binary composition star for the set 1 omega omega square under binary composition multiplication set generates a group G. So we can write that S under binary composition star forms a group. So this is the definition of group. I hope you like this video. Thanks for watching.